Hi everybody, welcome to Unit 3, Video 5. If you do not have your notes out, please go ahead and take those SM notes out now. All right, so it says, I can solve polynomial inequalities. Okay, so what we need to do is we need to figure out what these x's would have to be in order to make this a true statement or a true inequality. And to do that, you have to start by saying, okay, well, what kind of numbers would be less than 0? So we know the numbers that are less than 0 would be negative. So we need to figure out where the negative numbers would lie. And since this is factored, that means we have to start by finding the roots. So just like we did last section, if we say x minus 4 equals 0 and x plus 2 equals 0, since they're set equal to 0 here, and I solve for them. So here I'd add 4. So I'd get x equals 4. And here I'd subtract 2. So I get x equals negative 2. My roots would be at negative 2 and positive 4. So that's where I need to start this number line at. I need to plot negative 2 and I need to plot positive 4. Okay, so now that I've plotted those two, I need to figure out which of these ranges or these intervals here, to the left of negative 2, in between negative 2 and 4, or to the right of 4, I need to figure out where the negative numbers would lie. So the way you do that is I like to break them into these sections right here. And you want to pick a number to the left of negative 2. So I'm going to pick negative 3. You can pick anything. I usually try to pick the closest number. So negative 2 between 4. Again, you want to pick the closest or the easiest number. So in this case, that would be 0. And then to the right of the root. So to the right of 4 would be 5. Now you can't use the root itself, because if you did and you plugged it in here, you already know it'd be a 0 here and a 0 here. So you have to pick a number to the left of the root, in between, and to the right. Okay, so then we need to plug in negative 3 into this inequality, and we need to simplify. So that's going to look like this. Negative 3 minus 4, parentheses, negative 3 plus 2 is less than 0. And then we're going to solve. So here we're going to get negative 7. And then negative 3 plus 2 is going to give us a negative 1 is less than 0. And then when I multiply those together, I get 7 is less than 0. So that means anything to the left of negative 2 is going to result in a positive answer, because this is a positive 7 is less than 0. All right, so now let's test this middle range here. So we're going to plug in 0. So we have 0 minus 4 times 0 plus 2 is less than 0. So when I simplify here, I get negative 4. 0 plus 2 is going to simplify to 2 is less than 0. So then I'm going to get negative 8 is less than 0. So that means anything in this interval here is going to give me a negative number. And then let's go ahead and test to the right. So we're going to say 5 minus 4 and 5 plus 2 is less than 0. So 5 minus 4 is going to give us 1. And 5 plus 2 is going to give us 7. So we have less than 0. So then we're going to have 7 is less than 0, which again means anything to the left here is going to, or anything in this range here, is going to be a positive number. But we said at the beginning, we need only negative numbers are less than 0. So the only one that makes the statement true is this middle area here. Okay, so now to write the solution, since this is less than, above the roots, you have to put an open circle. Open circle. It means it can't include negative 2 or 4 as a solution, but it's everything in between those. So then we're going to say, we're going to connect it. And then we want to write the interval. So you always want to write it in interval notation. So we say parentheses, negative 2, comma 4, parentheses. Because parentheses means it's not included. So your answers are anything from negative 2 to 4, not including negative 2 or 4. All right, so let's go ahead and go to the next one. So again, you always want to start by saying, okay, this is x minus 3, x minus 1 is greater than or equal to 0. So the numbers that would be true are positive. Positive numbers are greater than or equal to 0. So start by finding the roots. And remember, to do that, you set them equal to 0. You say x minus 3 equals 0, x minus 1 equals 0, add 3 here, add 3 here, x equals 3, add 1, x equals 1. And again, you can probably tell, remember, we talked about the roots. They're just the opposite of what you have in here. So since this was -3, you have a +3. -1, +1. So then your next step is to plot the roots on your number line. And I always like to make them bigger. So I know that these are the roots. Or you could do them in other colors. So here's 1, and here's 3. So remember, you always do your number line least to greatest. Okay, then if you wanted to switch colors, you could. You pick a number to the left of your root. So I'm going to pick 0. You pick a number in between your root, so between 1 and 3, so 2. And then you pick a number to the right, so I'm going to pick 4. All right, so now we have to plug these numbers in and see where the true area would lie. So I'm just going to draw a little line here. Okay, so I'm going to plug in 0 to my equation. So that looks like 0 minus 3 times 0 minus 1 is greater than or equal to 0. So then when I simplify, I get -3 here and -1 greater than or equal to 0. So then when I multiply them, negative times a negative turns into a positive. So I get a +3 is greater than or equal to 0. So that means anything in this range is going to end up with a positive answer. All right, so now let's test one in between here. So I'm going to plug in 2 this time. So 2 minus 3, and then 2 minus 1 greater than or equal to 0. So 2 minus 3 is -1. Then 2 minus 1 is 1. So when I simplify here, -1 times 1 is -1 is greater than or equal to 0. So that means anything in this interval here is going to give me a negative answer. All right, so then I pick to the right of the root. So I tried 4. So let's go ahead and plug in 4. So I get 4 minus 3, 4 minus 1, greater than or equal to 0. So I get 1. 4 minus 3 is 3, greater than or equal to 0. So 3 greater than or equal to 0. So anything to the right here would give me a positive answer. Okay, so the true statements, because we need positive numbers are greater than or 0, was anything in this first range here and anything in this last range. So again, we look at the inequality sign. This is equal to, so now we know 1 and 3 can be included as a solution. So we make those shaded in circles. And we said everything to the left of the root and everything to the right of the root. Those were our true statements. So now to write this interval, we are going to say parentheses. Your eyes read left to right. Remember, to the left over here is -infinity. It's parentheses because you can't capture it. So parentheses -infinity. Your eye stops here at 1. It's a closed circle, so it's bracket. It's included as a solution. Or, so we say union. Then our eye starts here at 3. It's included, so it's a bracket. 3. And it goes on to the right forever and ever, and to the right forever is positive infinity. So then this is your interval. Okay, so now these two, the roots have already been easy to identify because the trinomial was already factored. But if you go ahead and look at number 3 and like number 4, it's not factored yet. So first what we need to do is we need to factor it. Remember, the first rule of factoring, identify a GCF. So yep, in this case there is a GCF. So we're going to factor out that y. So once we factor out the y, we're left with y minus 3 is less than or equal to 0. All right, now there's nothing more to factor. It's already simplified. So we need to identify the roots. Remember, this number on the outside counts because it says y equals or y is less than or equal to 0. So we say if the roots are y equals 0 and y minus 3 equals 0, then here if we add 3, you would get y equals 3. So our two roots are 0 and 3. So next step, draw your number line. We're going to draw our number line, and we need to plot our roots. So we have 0 and 3. Okay, if you want to switch colors, you can. The next thing is to pick numbers to the left, in between, and to the right of the roots. So to the left of 0, I'm going to pick -1. So -1. In between 0 and 3, I'm going to pick +1. And to the right of 3, I'm going to pick 4. All right, so remember, this is saying y times y minus 3 is less than 0. So the numbers that are less than 0 are negative. So we need to figure out where do those negative numbers lie. Okay, so let's go ahead and plug these in. And you can either plug it into the one you factored or the original equation. It doesn't matter. As long as you do the one that's set to 0, you can simplify. I'm going to pick the one that we factored. So that's going to look like this. So you're going to say negative 1, parentheses, negative 1 minus 3 is less than or equal to 0. So negative 1, parentheses, negative 4 is less than or equal to 0. And then when I multiply those together, I'm going to get a positive 4 because negative times negative is a positive. So I get 4 is less than or equal to 0, which means anything in this interval is going to give us a positive number. All right, so then I'm going to test the one in between. So I get 1, parentheses, 1 minus 3 is less than 0. So 1 times negative 2 is less than or equal to 0. So negative 2 is less than or equal to 0, which means anything in this range here is going to give us a negative set of answers. All right, and the last one, so we get 4, parentheses, 4 minus 3 is less than or equal to 0. So 4 times 1 less than or 0. So 4 is less than or equal to 0. So that means anything to the right of the root here is going to end up in a positive answer. So here we have less than or equal to 0. So the numbers that are less than or equal to 0 are negative. So it means our solutions are in this range. And so again, you look at the sign. So it's less than or equal to. So it means it's included. So you're going to do close circle, and it's everything in between. All right, so then we need to write our interval. So since these are closed circles, they're included. So we say bracket 0, comma 3 brackets. And so this is your set of answers. Okay, I want you to try the next two. So try 4 and 5. And remember, you need to factor, find the roots, then plot, and then test your intervals, okay? So go ahead and pause the video and try number 4. Okay, let's go ahead and see how you did here with number 4. So when we factored it, this was a difference of squares. So we got y plus 1, y minus 1. So that meant our roots were here at negative 1 and positive 1. And then we needed the negative numbers. So that was in this area here when I simplified. So it's everything in between. All right, let's see how you did with number 5. So on number 5 here, this one, again, you had to start by factoring the GCF, which was y. Then, if you noticed, y squared minus 16, that's a difference of squares. So you had to factor again. So in this case, you have 3 roots. You have y equals 0, y plus 4, and y minus 4. So when you solve those, you're going to get 0, negative 4, and 4. So if we go ahead and plot those, now we have more ranges we need to test. So we said we have negative 4 as a root, 0, since y is on the outside here, and positive 4. So again, just like we've been doing, now the only difference is you have more ranges to test. So let's go ahead and do that. Here I'm gonna try negative 5. Between negative 4 and 0, I'm gonna try negative 1. Between 0 and 4, I'm gonna pick 1. And to the right of 4, I'm gonna pick 5. Okay, so again, this is just more work. And so remember, you can plug it into any of these 3 equations, whichever one you feel is easier. I'm going to do the top one because I think it's just less steps, but it doesn't matter which one. So I'm going to plug it in. So negative 5, the quantity negative 5 cubed minus 16 times negative 5 is greater than or equal to 0. So when I simplify that, I get negative 125. Negative 16 times negative 5 is a positive 80, and it's greater than or equal to 0. So negative 125 plus 80 is a negative 45. Is greater than or equal to 0. So it means anything in this range is going to give us a negative. So now I'm going to test negative 1. So the quantity negative 1 cubed minus 16 times negative 1 is greater than or equal to 0. So negative 1 plus 16 greater than or equal to 0. So 15 is greater than or equal to 0. So anything in this range is going to give us a positive answer because it's a positive 15. So then I'm going to check this one. So 1 cubed minus 16 times 1 is greater than or equal to 0. So I get 1 minus 16 greater than or equal to 0. So negative 15 is greater than or equal to 0. So anything between 0 and 4 would end in a negative answer. And so then let's try 5. So we have the quantity 5 cubed minus 16 times 5 is greater than or equal to 0. So 125 minus 80 greater than or equal to 0. Oops, greater than or equal to 0. So I get 45 greater than or equal to 0. And so then anything here is going to result in a positive. All right. So if we look back to our trinomial here, it's saying greater than or equal to 0. So the numbers that are greater than or equal to 0 are positive. So that means the two ranges lie where I see these positive answers. So it's greater than or equal to. So it means I'm going to put a shaded circle, and shaded because they're all going to be included. So the first range of answers I have is between -4 and 0. This area is negative, so I don't do anything with it because I'm only looking for the positive areas. And so then this one would be everything to the right. So then your set of answers would look like this. Okay, so now we have to write the interval. Remember, your eye goes left to right, so we're starting with this -4. It's a closed circle, so we say bracket -4. It goes here, it stops at 0, and it's a closed circle, so it's a bracket. Or the solutions start here again at 4, including 4, and they go everything to the right. Everything to the right is positive infinity. It never ends, so it's parentheses. Okay, so make sure when you have more than one root, you're plotting all the roots and testing more of the ranges. So for 36, what we need to do now is remember everything needs to be set equal to 0, and the variable always has to go on the left-hand side. So the first thing I'm going to do here is I'm just going to switch this around. So this is saying 36 is less than x squared. So I'm going to rewrite that as x squared is greater than 36. Now to get it set equal to 0, I'm going to subtract 36 from both sides. So that's going to give me x squared minus 36 is greater than 0. Okay, so now that I have this, I can factor. This is a difference of squares, so I get x plus 6, x minus 6 is greater than 0. All right, I want you to pause the video and try to solve from here. Okay, so let's go ahead and take a look at number 6. So we needed to find positive numbers. Positive numbers are greater than 0. So once I did that, the ranges were here. Everything to the left of -6 and everything to the right of 6 would resulted in positive. So then this is what my diagram looks like. And then my interval. Remember, everything to the left here is a negative infinity. It can't be captured. So it's parentheses, comma, -6. It's open circle because it's not equal to, so it's not included as a solution. So it's parentheses, or, so union, parentheses 6 to infinity. All right, so let's go ahead and try number 7. So with number 7, what you need to do first is you need to factor it. And then once you factor it, then you can find your roots and solve. So for here, you're saying, what are the factors of 2 that add to 3? Well, the factors of 2 that add to 3 are going to be x plus 2 and x plus 1. So it's less than 0. So now that we factored it, go ahead and find the roots, plot it, and then write the interval. Okay, let's go ahead and see how you did. So our roots here were -2 and -1. So when I tested -3, I got positive. When I picked in between here, so I did -1 and 1/2. So then when I simplified, I got negative is less than 0. And here in this range, I got a positive. So the numbers that are less than 0 are negative. So it meant in between this range. It's not included because it's not equal to, so open circle. So then I got parentheses -2, comma, -1, parentheses. All right, for the next one, again, remember the first thing you have to do is set equal to 0. So what you want to do first here is you're going to subtract 2x from both sides. So you're going to subtract 2x, and then you're also going to subtract 4. So once you do that, you're going to get x squared, negative x and negative 2x is going to give you negative 3x, and then minus 4 is is greater than or equal to 0. So now that we have x squared minus 3x minus 4 is greater than or equal to 0, go ahead and factor that. So then go ahead and factor it, find the roots, plot, and write the interval. Okay, so let's go ahead and take a look. So is everything to the left of -1, including -1? Everything's to the right of 4, including 4, because that's where the positive numbers would lie. So then when I write my interval, it's to be parentheses negative infinity to -1 bracket, or bracket 4 to infinity. All right, so let's go ahead and go to the next page here. And so now what we're doing is the same thing. So what I want you to do, just like we did on the last one, is first thing you have to do here is set it equal to 0. So you have to subtract 3a and add 6, then factor. For this one, you're going to have to distribute the 4x, then subtract the 3, and then set equal to 0, and then factor and do the roots. So go ahead and pause the video and try. Okay, let's go ahead and see how you did here. So for number 9, once you combined all the like terms, you should have got a squared minus 5a plus 6 is greater than 0. So then it meant we had to find the positive answers because those are greater than 0. So these were these two ranges here to the left of -1 and to the right of 6. So then here's what the diagram looks like. And the interval would be -infinity to -1 parentheses or parentheses 6 to infinity. Okay, so for number 10 here, once you distributed and combined all like terms and set to 0, you would have gotten this 4x squared minus 4x minus 3, which would factor into 2x plus 1 times 2x minus 3. If you don't know, or if you can't factor right away into this, then you have to do the grouping method. So up here is where I did the grouping. So remember, you make your x, you multiply 4 and -3. So you say -12, that adds to -4. Then once you rewrite it and expand it, you can put it in your groups. And then once you group it out, remember you put the GCFs in 1, the 2x minus 3, since they're same, you bring one of them down. So that's where I'm getting 2x plus 1, 2x minus 3. So again, if you can't go from here to here, you have to show your grouping. So then to get the two roots, in this case, they're going to be fractions because there was a coefficient in front of the x. So we have -1/2 and 3/2. Again, we test all of our ranges. Since it's less than or equal to 0, we're looking for negative numbers. So the negative numbers would lie in between here. So since it's equal to, close circle, everything in between. So to write the interval, bracket, it's included. So -1/2 to 3, bracket. And again, in this case, you might have had to do the factor by grouping if you couldn't find the factors right away. Okay. All right. Let's go ahead and take a look at number 11. So what we need to do here is we need to go ahead and add that 2x over so that we can set it equal to 0. So we're going to add 2x to both sides. And then let's rewrite it. So we get x squared plus 2x plus 1 is greater than or equal to 0. I don't like the way that looks. So 2x plus 1 is greater than or equal to 0. That looks better. All right, so now we need to factor it. So the factors of 1 that add to 2 are going to be 1 and 1. So we get x plus 1, parentheses x plus 1, is greater than or equal to 0. So now what we need to do here is we need to plot. And in this case, if you notice, they're both going to be the roots of -1, which before we had called the double root. But we only need to plot it once. So we need to check the numbers to the left and to the right. So to the left of -1, I'm going to try -2. And to the right of -1, I'm going to plug in 0. And so remember, you can plug it into the trinomial that's set to 0 or the factored form. I'm just going to do the factored form. So here, I'm going to get -2 plus 1, -2 plus 1. -2 plus 1 is greater than or equal to 0. Okay, so then when I simplify here, I get -1. And then here I have -1 greater than or equal to 0. So then I'm going to get -1 times -1 is going to give me +1 is greater than 0. So that means anything here would be a positive. So now let's plug in 0. So 0 plus 1. So 0 plus 1 is greater than or equal to 0. So now I get 1 times 1 is greater than or equal to 0. So 1 is greater than or equal to 0, which meant these were also positive answers. So if I look here, it's saying greater than or equal to 0. Well, positive numbers are greater than or equal to 0. So I know it's closed circle because 1 is included, or I'm sorry, -1 is included. And it was everything to the right because those are positive numbers and everything to the left. So this is what we call a special case because everything is included. The solution is called all real numbers. And the way you write that is, so everything to the left is -infinity. This is included and it goes to the right to positive infinity. So we say parentheses, -infinity, comma, positive infinity. And in words, it would be all real numbers. Okay, so if everything is included, all real numbers. Okay, so let's go ahead and take a look at this one. Again, we need to set equal to 0. So we're going to subtract 4x from both sides. So we're subtracting 4x. So when we do that, we're going to get x squared minus 4x plus 4 is less than 0. And then we need to factor it. So when we factor it, we're going to be left with x minus 2 and x minus 2 is less than 0. Because those are the factors of 4 that add to negative 4, but multiply to a positive 4. So then when we graph our roots here, again, it's the same number. It's a positive 2. It's that double root we had talked about last time. So we need to pick a number to the left of 2. So I'm going to plug in 0. So I'll plug in 0. And to the right of 2. So I'll plug in 3. So when I check 0 over here, I'm going to get 0 minus 2 times 0 minus 2, which is less than 0. So this is negative 2. Negative 2 is less than 0. So I get 4 is less than 0. So that means it's going to end up as a positive. On here, when I plug in 3, I get 3 minus 2, 3 minus 2 less than 0. 3 minus 2 is 1, so I get 1 less than 0. 1 times 1 is less than 0. So again, I get positive answers. Well, positive answers are not less than 0. So since they're not less than 0, none of these answers would be right. So this again is a special case called no solution, because nothing would make it a true statement. All right, so go ahead and take a look at 13 and 14. You want to combine all the like terms, set to 0, and then find the factor, find the roots, and solve, okay? So go ahead and pause the video and try those last two. Okay, so let's go ahead and see how you did. So with number 13 here, once we moved the negative 4x over and subtracted 12 from both sides, and then simplified, you got x squared minus x minus 12 is less than 0. So to factor those, that's x minus 4, x plus 3 is less than 0. So our two roots were negative 3 and positive 4. And we're looking for the negative numbers because negative is less than or equal to 0. So that was in this middle range here. So then my interval, since it was closed circle, bracket, negative 3, 4, bracket. All right, for number 14, once I subtracted the 4x and added the 24 and combined the like terms, I get x squared plus 11x plus 24. So then the factors of 24 that added to 11 were x plus 3, x plus 8. So then my roots were negative 8 and negative 3. So then again, here with this one, I was looking for negative numbers. Negative numbers are less than 0. So the negative numbers fell in this middle range here. So then this one was open circle because it's less than, they're not included. So it's parentheses negative 8 to negative 3 parentheses. All right, thank you for watching today's video.